I was very fortunate to be an instructor at this class with Baileigh at Kindigit. I've been working with Baileigh for a long time. We've got a good relationship. So I've been doing these for many years, and it was awesome to be invited to come to this class. We have a wide variety of different instructors with different backgrounds and techniques. So even though I'm an instructor at the class, I like to see how other people do things to potentially grow my skill set and knowledge and understanding of metal shaping. I always recommend these classes to everybody. Even if you've taken it in the past, it's great to get new experiences with new students and different instructors that come through. So highly recommend to everybody. Show you a little bit more practical automotive-based bead rolling techniques just for finishing and how to kind of calculate pre-stretch. How many people have bead rolled stuff in the past? How many people have bead rolled something and then it's kind of twisted up and it's got a potato chip to it and you can't get it to lay flat? So I'm going to teach you how to calculate that mathematically so you don't get that. And for those that haven't had that problem, this is what I'm talking about. So this was a flat piece, we've bead rolled it, and as the bead roller has come through, it has drawn the material up and borrowed it from the surrounding area, which causes panel tension, and it gets you this shaped piece. So how we calculate that is we have to measure what is taken by each bead profile. So how I like to do that is I will do a test piece of whatever the profile is. So here we have a 1/4" round bead, so we're not going to get a huge difference. But if you get more complicated profiles, if you're using the Pullmax, anything like that, you're going to get a much greater distance. And you can measure this with a tape measure, calipers, but one easy way to do it is you can use tape as a reference. So this single blue line is going to be where we're going to bead roll, and we're going to roll from one end to the other, and it's going to shorten this piece by whatever the draw amount is. So we're going to take an ultra-fine Sharpie because we're going to aim small and miss small. If we use a giant Sharpie, now we have heavy 1/4" that we have to measure to. So we're going to get an inaccurate measurement. So if we take an ultrafine Sharpie and we just put a reference point on both sides of this line, it doesn't matter where or what that distance is, as long as it's wide enough that the bead profile can run through the middle of it. And we'll take a piece of 3/4" masking tape. And we're just going to put those reference marks on there that line up, kind of like that. So again, the marks don't matter distance-wise because all they are is a reference point. So I'm just going to label that top so I put it back on the same way. So then we'll peel this off and just stick it here for now. And we will come over to this bead roller. And we're just going to roll from one end to the other. We're not going to do anything that's trapped inside for now because we're just calculating what is lost. And again, we're not going to get a whole lot of difference with a 1/4" because it doesn't really draw a lot. But if you're doing half inch, 3/4, more complicated like belt lines for Model A's or 34s that have a lot more surface area to be drawn, you're going to get a drastic difference. So then we can take our reference and line it back up to the top and to the bottom. So what I'm going to do is I'm going to pass this around, and you can see that it's just slightly different. So how we would pre-stretch this is we would make the same reference marks, and then we could put a secondary mark of how much it needs to be stretched. So you put the reference marks in the same spot, stretch in that area until it moves out the distance that is lost. Again, if you measure it, say it goes from 1 inch to 0.78, you need an 1/8 inch of growth, so you would pre-stretch that an 1/8 inch to get the panel overstretched and give enough surface area for the bead profile to take that back. So I can pass that around. It sounds way more complicated than it is. You just kind of have to play with it, but it's going to be a weird process because the panel is going to get twisted and bunched up before you put the bead in, and then when you put the bead profile in, it's going to take that material and lay right back down flat. So it's, until you've done it a few times, you're going to be like, I'm screwing this up. It's not really doing what it should, but just trust the process, pre-stretch it, and get it to lay back flat, because that's, to me, that's a more professional fit. You're not putting a bunch of weight or clamps, welding it in, and having built-in tension. You want all of your panels to be relaxed. Are there any questions about this?
Like if you were going to do 10 of those, you have to...
You pre-stretch it everywhere that it's, everywhere that that profile is going to go. Personally, I like to work efficiently. I've got a power hammer, so I would power hammer it. But any way you can stretch, wheeling machine, planishing hammer, hammer and dolly on a steel table, whatever process you have at your disposal, use it. There's like a lot of black magic around pre-stretch. You know, some people say you don't need to pre-stretch, some people say you do. But anytime you're changing surface area, especially locked inside of a panel, like if you just went end to end, the panel would just shrink. But if you're stopping inside the panel, you're not getting that draw at the end, and that's why you get your bunching. So anytime you're changing surface area at all, you need to give the material a little extra to draw from.
Do you ever use the rubber die?
Well, the rubber die you're going to stretch with elasticity. It's not as easily calculatable because you're using the power hammer with the spring. It's not a dead set, like a fixed stroke or with the planishing hammer. It gets out of control a little bit easier. You could, but that wouldn't be necessarily my plan of attack.
So if you're stretching, let's just say you want to pre-stretch just this area, correct?
Yep, just where your profile is going to go. Because I'm not a very intelligent person, and I have to break things down to the most basic level so I don't overcomplicate. The only thing that takes this panel from being flat to kind of twisted is the effect in this area. So you only want to change in that area to counteract that effect. It's the same thing when you're hammering out weld seams. Your weld seam is here, you're not hammering over here because your weld and the heat affected zone is the only thing that's changed. So I can pass this around. Everybody check it out. It's just a very small difference, but again, this is with a 1/4-inch bead profile. The bigger the profile, more complicated, the more drastic the pre-stretch is needed. So the next thing I want to talk about is coining the ends of your bead. This looks okay, where they just kind of fade out into nothing. But if you want to step your game up, you need to coin the end of each bead. It'll help settle the end down and give a nice, crisp finish. I make a tool, which is a coining tool, but you can use a piece of pipe, you can use leather punches, anything that has the correct radius you want. Some people use open-end wrenches. Anything you can do to settle that end back down. So this is what the tool looks like, and it just matches the inner diameter of our profile, and it's just machined out. So I'm going to do one, and then if anybody wants to try it at this stage in front of a large audience, you're more than welcome to come up. If not, we can work on this later. But it's a super simple process. It does just take a little bit of practice to figure out how hard to hit it and to make sure that whatever tool you're using is squared off properly. If not, you'll get a little bit of a tooling mark, which isn't the end of the world. So here you can see the end is a lot more rounded and clean. It's a little messy, just I'm not used to this base. I've got one in my toolbox I can pass around, but you just want to finish off that bead. It just gives it a more professional, finished off look, like it's been stamped versus rolled. I only brought one with me, but I do make them and sell them. But again, this isn't really a sales pitch for me. I want it to be more a practical application for you. Because like the only reason I made a tool for it is you get pieces of tubing that are this length, and you get a whole box of them, and you got to dig through. And like these, they take up a lot less space and easier to organize. But open-end wrenches, leather punches, pieces of tubing. If you have a laser or a CNC plasma, you can cut out a little horseshoe to do it. Whatever you have at your disposal. If you don't have any of those, I just brought a soft face chisel. You can use a steel chisel and kind of dull it, and you can do the exact same thing. You can come in and you can lightly chase all the way around that and bring that edge down to get it settled in place. So there's a million different ways to skin a cat, but you just have to find out which way works best for you. And that's one thing I like about this class, is we're bringing in a lot of people with a lot of different experience, different equipment, and backgrounds. So we're going to give you all the basic knowledge on how to better yourself, and you have to take little bits from everybody and see which way works with the tooling you have, your experience, and how your brain processes information. For this demo, I'm going to do a one-piece Model A wheel well, but we're going to do it in aluminum, and Shane's given me an hour, so I've kind of condensed this down. So we're only going to do roughly half of it. So I brought the pattern for it. Pattern making is key, and I'm going to try to keep the talking to a minimum just so I can show you how aggressive of a shrink you can get. But the pattern is critical because we're creating our roadmap to make our part. I'm very critical when I go to make my pattern, because if I give myself false references, a terrible roadmap, I'm going to get terrible results. So I can pass this around and you can check it, but as I pull it over, our pattern or our buck, the pencil line is the center line of our radius or our light line, and I've made a mark on where the start of our radius begins, the center, and our end. And you can calculate that by taking what the radius or the diameter of what you want that to be. So we'll just say it's a 3/4 inch radius or an 1.5 inch radius. You can divide that by 4, multiply it times 3.14 or pi, and that gives you your arc length. So you can calculate that to give the offset off center, or you can just make the pattern if you're not good in math, because I'm terrible in math, but I have to have a way to keep track of what I'm doing, or I'll lose focus and I won't get a repeatable part. So all of the wrinkles or the tucks, just like Carl laid out in the metal, it's going to show up in the paper, and you can see that it's a triangular shape. More shrink is required at the end than is needed at where it starts at our light line. So I'll pass this around, you guys can check it out. If you have more questions about it later, feel free to just pull me to the side, or while we're doing your demo, you can ask. But I'll keep the boring stuff to a minimum, so just guys check that out. And after I make the paper pattern, I lay it out exactly the same way on our material. So we have the start of our radius, the center of our radius, and the end of our radius. So our first set of shrinks is going to go to the start of our radius, our second set to the center, and our third and remaining sets of shrinks to pull over to a 90 are going to be at the end of our radius, working outward. So we're going to bring this up, pull it over to an 1.5 inch radius, and then straight out at a 90, so we have a mounting surface on the car. Do we have any questions about kind of the abbreviated layout to this point? Everything that is SH is shrink. I label it because, again, I can't keep focused. You know, I'm like a lot of you guys. You see a squirrel, I'm gone for the day. So I really have to keep everything labeled so I can keep track of what I'm doing. Any distraction is going to be detrimental to the panel, so I have to keep a clean train of thought.
Did you say you're taking that over to a 90?
Yes, but with a radius in it. So if you were to shrink to just one of these blue lines constantly, it'll be a crisp 90. If you want a radius, that's where you have to calculate the arc length.
Cool.
Did you transfer your lines by using a spring punch?
Yep, so the center line I've measured off the pattern, and I use a spring punch to mark it. And then on there it says each line is offset, I think it's by 0.75. So then I use 3/4 inch masking tape off of that center line to offset the start, center, and stop of the radius. I like to work in masking tape a lot. That way I'm not trying to use a tape measure and measure that offset. Masking tape comes in variable sizes, and it's very consistent. So then you can always offset the same amount, and you're not worried about making a mistake while measuring. Any other questions at this point? We ready to make some noise? So one thing I really like about power hammer work is that you can shrink with it. On a wheel, you can't use the machine to shrink. And you're limited with shrinking in a stump. Usually you can only go in maybe 4 to 6 inches unless you get really aggressive. I've just never had any luck with that. With a power hammer, you can shrink as deep as the machine throat is as long as you're man enough to hold on to it. This is a 19-inch depth. I've never shrank 19 inches in. My bigger hammer is a 37-inch throat. I've never needed that for shrinking. It's always low crown work. So this is a pretty aggressive piece to pull that much over and do it in one piece. The reason I like to do that is it saves time, it saves energy, and I hate welding. So if you were to do this in 2 pieces, you'd have to file, fit, get everything perfect, weld it, metal finish it, and dress it. Or you can do it in one piece and you don't have to worry about any of that. So I've got our thumbnail dies set up. I haven't ran an MH19 in a while, so hopefully it's pretty close to the settings we need. And when you're doing aggressive shrinking, you need some kind of chest protection because you're going to use your body to help support the panel. If you're just wearing a t-shirt, the metal could cut through your shirt, cut through your chest. It's going to be a bad day. So you always want to wear some kind of apron or thick shirt to protect yourself from the edge of the material. Yep, so we've got our thumbnail dies. I've checked the tool gap, which I like to set 3/16 to 1/4 inch. Our stroke is set halfway through to start. So what I'm going to do first is I'll just pick a line and I'll come in and I'll put a tuck in it and I won't close it. I'll pull it out of the machine, let you guys see the tuck out of the large thumbnail dies versus how Carl was doing it with a tucking fork or the stump, just to show you the difference. And I will put it back in and then I will close the tuck as I come out. Pay attention to what my body is doing. My hands and my feet know more than my mouth does. You know, after 20 years in the industry, I'm not so great about talking about what I'm doing. I just focus on the task at hand. We ready to rock and roll? Yeah. So that's our tuck, and it's nice and consistent and smooth. And when you're using thumbnail dies, the most critical thing you need to focus on is your starts and stops. Where it stops is not the edge of the die, and it's not the edge of the thumb. There's a little kidney bean shape that kind of floats right in the center of that. So as you look through the tooling, you will watch for that kidney bean shape to come up, and that stops at your light line. If you don't have consistent starts and stops, your light line is going to be inconsistent. So there's going to be a lot of repetitive word usage. Consistency is key because you want your light line to be nice and smooth, even. It's less for the body shop to try to correct later with filler. So just be consistent, focus on starts and stops. Hitting those points in your panel will be that much better. So I'll go ahead and I'm going to turn the stroke up just a little bit.
Are you saying your light line?
Yes.
Light line?
Yeah.
Reflection, right?
Yep. So Carl said something about metal being more like clay or dough. I like to think of metal being more of a fluid, and you can manipulate it any way you want. But like you were asking with the light line, it's anywhere that you're going to change direction or add or reduce surface area, and it's going to get that light to bend. It could be a hard aggressive peak like a body line, or it could be a low crown or a reverse section. So you look down the side of a car, an airplane, a boat, anywhere the light changes direction is going to be a light line or a highlight line. Just depends on which one you want to call it. So I'll close the tuck, show you that, and then we'll just get in and I'll start knocking them out. So there our tuck is closed, and when I get to the end, I like to feather the pedal back. There it was pretty easy to see. When you start getting in working faster, that's going to be like a pedal pump at the end. I just like how nice and consistent and repetitive that is. I'm kind of lazy. I don't like swinging a mallet. So to shrink that much, I would have worked a lot harder and taken a lot more time. And in a production type setting, efficiency is key. You know, you can't charge 100 hours if it only takes 5 hours to make the part. So for me, it's all about efficiency and being able to have a high quality part at a reasonable price for my clients. So any questions? No? All right, so I'm gonna go in and I'm gonna shrink on our blue lines, which come to the start of our radius, where it's gonna start the transition, and I'll come back step to the black line, which is the center of our radius, and then I'll come back to all the lines with the little red arrows, and that is gonna give us more shrink to that point, and then it'll just be a ton of shrink off the edge to get that to pull over and be tight. You're gonna see this edge get really loose because we're shrinking here, but we need so much more shrink here that it's gonna get super waffly and loose, but as I shrink off the back, you'll see it start to tighten up. So that's our set of shrinks to our line, and you can see that it's kind of pulling this way and this way. That's just a form issue. So what we can do is we can pull that against ourselves or push over our knee and adjust that form and get this a lot flatter. So here you can see what I was talking about. See how that edge is kind of wicking out and it's super loose at the end? But if you look, I'll try to pan it so everybody can see it. We have our flat surface and our radius, and it crosses that radius and starts to wick out. We need to tighten all of this up. So I'm going to start to shrink just to the end of our radius, and I'll come in and I'll shrink there, and then I'll divide that into a third, and divide that into a third and tighten the edge. That's because we need more shrink at the edge than we do at our light line. And then I'll repeat that process until it pulls over. So that's our second set up to that radius. And you can see that it took all that looseness off of our edge. But now we have two different radii coming together. We have our tight radius here and then a lower crown radius off the top. But that's not what we want. We want that to pull to a 90. So we repeat that process and come back to that line and repeat. I did get a couple coins that Chris was talking about at the end. It happens. It's not ideal, but when you're doing a lot of shrinking and trying to work fast, it's bound to happen. So as you guys are on the hammer later, you're going to coin the end. It's not the end of the world, so don't sweat it. So I'll come back and I'll do another set up to that line and work my way out. So you can see we're getting closer to that 90 degrees. Just adjust the form a little bit. So anytime I make something, I add a little bit of buffer for either coining or it's just a safety net, because if you cut it exactly the size, it has to fit perfect. Things migrate, light lines move. So if you add that extra buffer material, you have a lot to play with. So here we're super close. I think all I'm going to need to do is come in, do one final shrink to that point, tighten the edge up a little bit, and we'll jump over to the other machine. So the initial lines were just a reference to get me to hit this radius. And you guys can see how clean and all the starts and stops are relatively consistent. And one thing I didn't mention, anytime you're working sheet metal, you're always going to pull shrinks or your linear stretches perpendicular to where your light line is. So your light line dictates everything. If we were to come in and shrink at a funky angle, that's going to pull inward at that angle, which is going to pull this corner around. So everything is dictated in a perpendicular fashion to your light line. We'll hop over to the other machine and get this thing cleaned up to where it looks like a usable part, not like it got ran over by a truck. We have a flat top master upper, and then we have a 36-inch radius lower. You want to use the lowest crown tool you can get away with. So since where that's at a 90 is going to be flat on one plane and a radius the other, that's what we're going to go with. And we're going to do just kind of quick and dirty at this point. And we're going to rough blend all of this out. So everybody that saw it, it's kind of got lumps and bumps where all of our shrinks have started stacking. We're going to blend all that out, and I'm going to planish up to our light line, or the end of our radius light line, and then we'll clean this radius up in the air planisher. Any questions? And I'm running the edge of our tooling right on that line so I can kind of dial our light line in as we go. I'm going to turn our stroke down a little bit and our RPM up so we can really buzz through there. Doing radial tooling, so 36-inch radius lower, it's spreading that force out in all directions at once. So it doesn't matter if we go left to right, forward, back, figure eight, squares, because it is spreading that load out in every direction. So I'll do like a left to right, and then I'll come in a diagonal. It's more about just working the panel as a unit and getting everything blended out. So don't be focused on in and out or directly left and right. You can move around in any direction because that force spreads out in any and all direction. So with everything kind of rough blended out, we've still got a little bit of a high here. So if it was a part I was going to use at home, I would come back and I would thumbnail shrink into that to drop it down. But for the sake of time and demonstration, we'll just jump over to the air planisher. We'll clean this radius up a little bit. We have an 1.5 inch radius tool. And we don't need a ton of air pressure. So I'm going to pass this around so you guys can check it out. I just planished here at the edge. That way you can see the start of the planishing, this blending, and then how it came off of the hammer with the shrinking. So I'll pass that around, and if you look, you can see the contact patches of the tight radius or the 1.5 inch radius tool. And that can be a problem if you're really trying to get a mirrored finish. So I like to use tools that aren't for their intended purpose. So this is a linear stretch die for the air planisher. And if you turn your air pressure way down, we could use this in that corner radius. So it's going to be the proper radius this direction, but lower crown this way, so we get a better contact pattern and really iron that out. So it just takes it from a 1/4 inch contact patch to a 1/4 inch by 1 inch contact patch. So don't be afraid to try different tools that aren't for their intended purpose. It is a linear stretch die, so it will stretch in a linear fashion, but a lot of that is controlled by how hard you're hitting. If you turn the pressure way down to where it's not hitting hard enough to do a bunch of stretching, it'll just refine surface finish. I'm really big on getting things mirrored. That's not for everybody, it's more of a pride thing. So it's kind of hard in this corner because it's dark. Use light, that's what we're bending, so use that to your advantage. Get lights around you, put a picture on the wall, something that you can see that reflection. And you know, if it's a picture of a car and you see a funky shape in that reflection that's not in the poster, you know that area needs addressed. So use every tool that you have, your hands, your eyes, lights, reflection, anything, to your advantage. And one thing I do that's a lot different than most, I like to dry planish. Like, I didn't put any lube on the panel. If I'm doing a lot of shrinking, especially on aluminum, aluminum is a dirty metal. It'll bring its own oils out. So when I'm doing finishing planishing, I will continually clean the dies and the material. If you have oil on it, it'll leave the panel dull. There is a texture in your oil. So the finer finish you have on your tooling, it'll burnish that material and really shine your panel up. So I keep them clean, oil-free. I just don't like planishing with oil. And you can get the most mirrored panel off of an air planisher if you do it clean and dry. So I'll pass this back around and you can see where it's starting to pull those small, tight radius hammer marks out. And another good rule of thumb is, say it takes you, what would it take, 30 minutes to shrink this over? Prepare to spend 3 to 4 times that amount planishing and refining. So power hammer is quick and dirty to the point. Refinement is just that, refinement. It's slow, it's tedious, and don't rush the process. So I'll pass this back around and you can see the surface finish difference, and you can just see all the little 1.5 inch radius lower tool marks starting to come out. So we could get it to where those marks are non-existent. It's just going to take more time than we have here. Mike Wagner, everybody? Yeah. Yep, and if anybody has questions, feel free to come find me and I'll answer them the best I can.